Hello everyone, it's September 30th. Alright, let's get to it. Another easy one. Let's blast it through. Given a string, reverse the order of the character in each word within a sentence while still preserving the white space in initial word order. Okay. There is at least one word. S does not contain any leading or trailing spaces. All the words are separate by a single space. Now, what you need to consider in this one is there are many ways to do this. Okay, so I know how to do it in Python, right? In Java, if you want to find the easiest way to do it, I think the best way to do it will be to turn it into a char array. I think that's the best way to do it, that I will approach it, is to turn it into a char array. Right? If we turn it into a char array, then we can say char s dot to char array, and then we're gonna have two pointers, right? Int I equal to 0 for int j equal to 0, j smaller than s dot. Now the char s dot length j plus plus. If chars j is equal to an empty, then we can say reverse. Now we need a function, we call it private void reverse. We'll pass a char array. We don't even pass a char array. We call it chars. Okay. Then we do this. Then we just need a low and high. So we'll reverse in this range. Now what we need to do is int I equal to low, int j equal to high. Okay, while low is smaller than high, and we have int temp. Okay, so we say, well, this temp equal to, oh, that's not int, that is char. So temp equal to chars I or equal to chars, right? And then chars j equal to temp. Then that's not low and high, dude. That's I and j. Okay. Then I plus plus, j plus plus, j minus minus, until we meet. So we'll swap, 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 swap. Then that's it. So we don't call reverse I and j, right? Once we finish reverse, actually this should be j minus 1 because j is pointing to the empty space, right? So once we're done, I shall equal to j plus 1 because j again pointing at this. Right, and then we go on, then go on and go on, and then we'll return chars, string dot the value of chars. Okay, let's give this a shot. Ooh, the last one is kind of messed up. The last one. Oh, of course, we forgot. We have to do that at the end, because at the end, when it come out, right? When they come out, the last one, we need to do a reverse ing. Yeah. Oh, J is out of scope. Shoot. Yeah, it's understandable. Out of bounds. Oh, okay. So J have to -1 here. Yeah. I think this is the fastest way. I'm not sure. Ah, I think so. Okay, let's put this one up. We need to make directory. Okay, so we are entering October. Time passed really fast. Okay, do you think there's any other way to do this? I use a string builder. Yeah, basically this one. Okay, so that's that. Alright, I think this is the last one. Just non-JavaScript. Oh, not the last one. We have actually one more we need to deal with, but right now let's just focus on this. Right now let's just focus on this one. Minimum deletions to make character frequency unique. I already forgot. I deleted how I do it is in the past, so let's just see how we should do it. A string s is called good if there are no two different characters in s that have the same frequency. So everybody, no two different characters in s that have the same frequency. Given a string s, return the minimum number of characters you need to delete to make s good. The frequency of a character is the number of times it appears in the string. For example, A, B is frequency, A is 2 and B is 1. So we want to make the string s to be good if there are no two different characters in s that have the same frequency. So everybody should have the different frequencies, right? That's what the premise is. Everybody has to have the different frequencies. So we make a counter, right? So we make a counter. Like in this case, we have A, B, 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 and C, C. So A we say has 3 times, B has 3 times, C has 2 times. So basically we have a list of numbers, right? It's 26 in total, okay? And it have 3, 3, 2, right? In this case, we have A is 3 times, B is 2 times, C is 2 times, D is 0 times, then we don't care, and E is 1 time, right? So we want to know what will be the minimum number to delete so that the frequency becomes unique. So in this case, can we like remove the letters altogether? Yeah, I can do both C's. You can do frequency 0. So when you think about this, right, so this is the first level of conversion. Now we convert into an array, right? We convert into an array. Then we want to know what's the minimum number we need to remove to make everybody in the array unique. Okay, so if we remove so we can find more frequencies. So 3 has frequencies of 1, 2 has frequencies of 2, 1 has frequencies of 1. So all the frequencies of 1s, we can say, okay, these are, we can choose not to remove them. And then we have a bunch of frequencies more than 1, right? Frequency is more than 1. And for the frequency more than 1, then we need to know so we want these numbers to be different, right? We want these numbers to be different. Now we have some number repeat themselves. So each one should have frequency of 1. So if your frequency is 1, that's it. If your frequency is not 1, right? If your frequency is not 1, then it's bad, right? We want to remove, basically we say that different letters have the same frequencies, right? So we need to remove to make you appear less often. But if I remove this, become 1, then we have 2 1s. You're increasing the frequency of 1, right? So you need to remove again. So that's why you have to remove both. Okay. Minimum deletion. Can we say like this, right? Like at the end, you'll have a list of numbers, right? And someone has repeats. Some might have 3 repeats, right? If you have 3 repeats, you have same repeated 3 or more than 3 times, like many times. So you have different letters. I just repeat that many times. And then you'll say you want to make all of them unique, right? You want to make all of them unique. So you have, like I say, someone 2 times, 2 times, 2 times, and they're all the same. So one of them need to reduce, right? And the other one, right? If we remove 1, we reduce back to 1. And for this, yeah, because each count, right? Each count can only appear once. So if I say I have count 1, I done it. Count 3, I done it. Now count 2, right? Now have count 2. So we can have count 0, count 1, count 2, count 3, count 4. Doesn't matter, right? another frequency. Now in this case in particular, count 3 taken, so you cannot take that anymore. Count 1 taken, you cannot take it anymore. So count 2, right? You look at count 2, we have 2 of them, right? So we can have 1 taken, right? So we have another one has count 2, right? Has count 2, repeated 2 times, but we cannot have 2 times. So this, the only place he can go, he can only go smaller. So you have to go to 0, right? So now there is a case you can argue, maybe count 2 can go to count 1, right? But if you do that, then count 1 has to go count 0. So I'll argue it will be the same. So basically what I was thinking is, right, as you go through everything, you will map out, right? So you do 1 round counting, you do a second round of counting, okay? 2 rounds of counting. Now you have the count of the frequencies, okay? So first you count the frequency of the letter, then you have the frequency of the counts in themselves. And you can, I just say like do a map, right? Because you don't know the count. The count can be huge. So you know the count, so you do a map, right? On a map, you map out if it's, you map everybody, okay? You map everybody, and then you have a sorted, okay? You have a sorted frequency, right? You have a sorted frequency. Along with them, you have their count. So you have a sorted frequency, sorted, yeah. So here I think you have a sorted frequency, 1, 2, 3, doesn't matter, all the way down. And then you have their corresponding count, how many occur at each positions. And you're gonna go from, I'll say this direction. Each time you encounter something with a count 1, you skip, because those are good. And you encounter something with more than 1, you have to make this, right? No matter what, you need to reduce this into a count 1. And if you do that into count 1, which means for this frequency, you will have to reduce to count 1. One frequency of one count of that frequency. Then you have to reduce to some other frequencies, right? Some other frequencies. Then you need to find the first spot that is open for you. First spot that is open. First spot that is open. Maybe you just go 1 by 1, right? You find the first one is open, you fit it in, right? And you can actually put this, I don't know, into a queue. You put it in, you say we have a current frequency, and then however many frequency we have additional, you just put it in there. These are the frequencies. And then you've hit the first one, you can put it in, and then you put this one in, and then you count how many letters you need to delete. So it's kind of greedy, right? Kind of greedy. And then you handle one, and then you just keep going, because you cannot go to the right to become unique. If you want to become unique, you have to go to the left, right? Because you have to remove. And then for the next one, you try the next one, you try it until you done this whole thing, right? Until you've done this whole thing. Now, there's one thing I'm curious, right? One thing I'm very curious about is the accuracy. Not accuracy, the proof. Like, does this one make sense? Is this one guarantees that you get the minimum? Now, my argument is for each frequency that has doubled, by doing it this way, you're going to the left-hand side, you find the first frequency that you can fit it in. You're always removing the minimum number of characters to fit this frequency. Because no matter what, you have a frequency that's duplicated, right? You have more than one count of that frequency. You have to reduce it to something, right? For any frequency you're given, if it's duplicated, you have to reduce it to something. And what we're trying to do is to reduce it to the smallest possible. And we have also shown that if you do a transfer, right, if you have in a frequency A, frequency B, and frequency C, right, if these two are 1, this one is more than 1, you can, from this, you can transfer to B, right, to make this one good, then B increment, then B transfer to A, and A transfer. So if you do this kind of transfer, it's the same as doing the C directly go here. So it's basically, you say you're a C, right, and then these are all adjacent. B you cannot dump, A you cannot dump, this one you can dump, so you can always dump here, right? So that's kind of the idea, right, the idea. So I'm going to implement this and see if this greedy-ish idea works. Now, to make this work, we need to have, we can have an array, a counter, right? So you have to count the frequencies. You need to have the frequencies. Then you need to count the frequencies, right? You need to count the frequencies, and you also need the maximum of the frequency to determine your count, like how long it's gonna be, right? And then you're basically just gonna go. You have to count that count of count, right? So you do a count of count, and then you sort it, right? And you go in. Maybe it's yeah, it's step by step. Okay, so first what we want to do is int char frequency. Okay, char frequency will be new int 26 characters, right? Then we say for int I equal to 0, I smaller than s dot length, I plus plus, char frequency. Okay, what is this? S dot char at I minus 97, because lowercase English letters. So now we have the char frequency. Next we want is a map of integers to integer. We're gonna call it frequencies frequency. Okay, so new hash map. Then we say for int f of char frequency, right? We say yeah, because this is 26, so it's f as at most 26, so this will be short. The key of hash map will be short. It won't be too much, right? It won't be too much, because this one will condense. So you only have 26, at most you have 26 numbers, right? 26 of frequencies. You have 26 frequencies, and then what you're gonna do is for this f in here, then we say frequency dot put. Okay. Frequency, and frequency dot get or default frequency. Default is 0 plus 1. So now we have the frequency. Okay, frequency. Then we need to sort the keys of that. Then we say int, or maybe it's integer, this frequency keys, sorted frequency keys shall equal to dot key set dot to array, and then so that's array, and then we can say arrays dot sort. No, we have to do it outside, so we do that, and then we say arrays dot sort sorted. Okay, So now we have the sorted keys from small to large. Then what you do is you go to, right? You go to, this is the sorted the keys. So it's like this frequency, how many times this frequency occurs, right? How many times this frequency occurs. And you're gonna go from the large to small, right? How many times this frequency occurs. And then what you need to know is for each one, right? You will go down. Yeah, because I'm thinking the implementations for each frequency if it's larger than 1, right? And then you need to go down. And then you will change. You will make change to the frequency. You'll put 1 to it. And then you will get the next one, right? Keep going down so you fill it. Okay. So I will say for int I equal to sorted this dot length minus 1, I large equal to 0, so we have to handle everything in I minus minus. Okay. And for each one we say if frequency dot get sorted frequency I, right? If that is equal to 1, continue, right? We're good with that. Now if it's not equal to 1, right? If it's not equal to 1, everything all right?
There's a cat right outside the window.
Wow.
The window was hissing.
Ay, ay, ay. Close the window.
I did.
Thank you. If it's not equal to 1, what we're gonna do is we'll go down the, we probably need to get the, let's say int current frequency equal to this, right? Let's get this out, and then current frequency. So if the current frequency is larger than, right, then what we shall say is while how should I say this? Shall be for int next frequency equal to current frequency minus 1, next frequency large equal to 0, right? Actually larger than 0, because 0 is a different thing. And next frequency minus minus, as it's, so we need to, it's larger than 0, and frequency dot get current frequency is larger than 1, right? When this happens, then we'll say if frequency dot get or default next frequency 0, right? If it's equal to 0, then we can put it in there. So and then now here I need to say int res equal to 0, right? So in this case, I will reduce whatever frequency I have to that frequency, right? Then we say frequency dot put next frequency 1, okay? And then we're gonna say frequency dot put current frequency dot get current frequency minus 1, and res plus equal to current frequency minus next frequency. That's the amount I have to reduce, right? So we do that if it's equal to 0. If it's not equal to 0, then we just skip. Keep going. And each time the minus 1, so next time we can check. So once we're done, right, once we get out, if frequency get current frequency, it's still larger than 1, right? Then no matter how many is in there, they have to all be reduced down to 0. Like those values they have to go, right? They have to go. So we're gonna say res or plus equal to the current frequency times it's larger than 1, it's like 2, 3, right? Then we can say frequency get current frequency minus 1. That's how many more we need to get rid of, and they have to all be getting rid of, right? And once we do that, we can say the output current frequency equal to 1. Okay, then that's kind of one round. Then we'll go back. And in fact, I don't even need this because this says it has to larger than 1 if it's equal to 1, right? If it's equal to 1, then we don't enter this loop. Equal to 1, don't enter this loop. So this is automatic continue. So we do that until we go through all the sorted frequencies. And when that happens, we'll return res. Okay, so this is kind of current solution I have. Let's see if this makes any sense. Okay, so this is good. Now with this, okay, so these are typical test cases. Okay, some gibberish, some regular stuff. It looks like we might have it. We might have it right. You want to try one more? Yeah, try one more. How'd you like this one? Oh, shoot. I think I typed the wrong letter. Sorry. Okay, if this one's correct, I'm gonna submit it. And by the way, I will subscribe because I need to do some JavaScript. Alright, I think this is right. Yes. Yes. I think I did better than last time. I mean, you can tell from the time complexity. Last time was pretty bad. I was like, oh my god, I don't even know what I was doing back there. What did I do? Number of unoccupied. Smallest available value. I think it's the same idea. I think, you see, I'm going through all the frequencies, right? But I use another stack. Yeah, I think this is the right one. So, miraculously, did it better than last time. So last time I solved this was September the 12th, okay? And I remember that I struggled a lot. And that was why I kept this problem here, so that I can try another method sometime later. Now it is sometime later, and then miraculously I have found a better solution. All right, now this one is based on the idea that we first find the frequencies, right, of each letter, Then we find the frequencies of the frequencies. And the goal is to make each frequency, frequency, equal to 1, right? Now what we can do is to first sort the frequencies, sort the letter frequencies. Then we start from the largest frequency. If a target frequency has already only got 1 count, we skip it because there is nothing to remove. Otherwise, we need to determine what new frequency to demote the current frequency to, right? And to make the demotion as efficient as possible, that is, with the lowest number of deletion, we need to find the largest frequency with 0 count, and we can simply, iterate, right? Iterate from the current frequency down, right, to find it. This won't take too much time because the total number of letter frequencies is not more than 26, right? So iterating from the current frequency down to an unused frequency shall be very fast. The worst case would be that we iterate all the way down to 0, which will cost no more than 26, right? 26 loops. Then we're done, right? Then we are done. I'll call it ON, because this is ON, right? N is the length of the letter, it's ON. This is basically O26 squared. So that's why it's fast. Okay, that was good. Did not expect this one to find a better solution than last time. I think it's the same. Now, the last time we had this idea, but the implementation just ugly. Awful implementation last time. All right, let's check what people's greedy, right? Greedy. Yes. Yes, it's the same idea. But why are you so much better? I need to read other people's so you have a set. So this is the count, right? And then this is to add. I get that. Did you use this? You use plus equal 1. You should do plus plus. And then while count is larger than 0, and this count is now used frequency, right? if count is larger than 0 and this count is not used, users use dot add. What is this? Use dot add. So basically this is we try to add it. If it doesn't, hold on, this is the letters frequency, right? It's larger than 0. And which means it's false, which means it's already in there. So it will add it if it's not in there. If it's not in there, we're good. If it's already in there, so the count is in there, then this will return false. Then you'll reduce its frequency. Every time you reduce the frequency, you add it. So it's the same idea, but better implementation. Yeah, it's a much better implementation. Yeah, you just reduce it every time you reduce, and all the way to 0. Nice. Same idea, but let's try to implement this. Should be very fast. So we can do this, and let's make it better by ++, right? Then we don't use this. We can say set, right, of integers, or we call it used, seen, used. Yeah, I like this one, used. New set, hash set, right? Then what do? Then what we need to do is to check every single one, right? And say for int I equal to 0, I smaller than 26, I plus. If char frequency I is larger than 0, okay, and used dot contains char frequency. All right, if it contains it, no, not if, it should be while, right? And it contains it, that means this has been used before, so I need to reduce it. Then we say char frequency I minus, and the rest plus. Oh, this piece is wonderful. This piece is wonderful. Rest of plus. Until it does not contain, right? Now we say if char frequency I is still larger than 0, then we will do use.add char frequency I, and blah blah blah, we'll return res. Okay, let's check this one. This one's inspired by this. Better implementation. Same idea, but better implementation. Okay, hold on.
Should we leave it closed? Or just like that?
All right, we're almost done here. I'm just saying, maybe I need to put better implementation. This is whether a letter count has been used before. So use a set instead of another hash map. That's why I think this one will be even faster. Exactly, right? That's the good part of Java, is every time you change things like this, it does become faster. It's not like in Python. You make these changes, usually it doesn't really make much of a difference, but here it really does. All right, that will be it for today. Okay, fast one. I will see you guys tomorrow.